Hello guys. So today I'll be giving a small talk introduction on Druid. So so what is Druid? So it's an Apache Druid. Actually, the full name is Apache Druid. So it is nothing but a high performance analytic data store where it is mainly used for event driven systems, and the main Apache Druid is built. Its core concept is built on OLAP databases. And for few people who don't know what is OLAP databases or analytic databases, is that uh, usually for analytics, you combine a lot of databases and try to get metrics out of it or your analytics. So that is OLAP databases and time series database. And time series database, the main component is actually your time. So based on your time, the database sorts and partitions itself. And search systems. Usually search system, you can say that log queries and those things. So it has taken the ideas from all these databases and systems and try to bring your system, combining them. So that is Druid, Apache database or a system which is very famous. You want to see who all are using it. So Druid is used in Netflix to monitor the infrastructure, and in Walmart to have even analytics stream. And in Airbnb, they have getting insights on the users on their platform. And many other companies use Apache Druid for their own use case.
Vru is also using it now, right?
Ru is also using it.
And Mindhouse is also using it. So Kanchan implemented Druid for Mindhouse for the analytics.
Yes, yes. So this gives us, this is very nice. And why should we use Druid? So one thing is that when you have an analytics query, you need it as soon as possible. So you can say it in sub-seconds or seconds. And one more thing which Druid is very good at is that uh, it has real-time streaming ingestion. That means as soon as usually what is streaming is as data is events are flowing in real time, you need to have get that analytics in the. So this Druid helps in real-time ingestion, which will help us that which will help us in getting metrics or running our analytics in real time as well. And not only that, but it even supports multiple queries at a time. So you can they call it as multi-tenant. So what happens is at a time, if hundred thousands of users can query and get their metrics and reports out of it. Upon that, it is very cost effective. The way it has for in a way which they have implemented it. And not only that, now we have built a Druid in a small cluster, if you say, and you want to start scaling it. It is very easy and aware to scale it. And not only that, it can also be it is very much available. If anything goes down, it can take care of itself. So that is why you must use Druid. And what are the key features of having Druid? One thing is that it stores in columnar format. And second thing is it is scalable distributed system. So you can run it on multiple instances, and it is massively parallel processing. And with that, it supports batch and real time ingestion. So in this way, if you already have your data in S3 bucket and you want to run on that, it can run that. Or if you have Kafka, Kinesis, it can connect to that and start ingesting data, and you can run your queries on that. And with that, since it is a distributed system, it can self-heal and balance its operations. And one more big thing is that it is very cloud native. The way the architecture has been implemented, that even if there's some problem, it stores the data in your S3 bucket or a bucket in your cloud storage. So in this way, it is very fault tolerant, and it indexes all its data. So because of that, you can do filtering very easily. And one more thing is that since takes a concept of time series as well, time series database. It partitions with respect to time. And since it has to give you very real-time analytics, so what happens is it has a lot of approximation algorithms where a very famous case is count distinct. So if you want to have a distinct count of any value, so you cannot keep running it on a huge data set. So there are a lot of approximation algorithms where in few seconds it just gives an approximate of how much it is. And another big thing in Druid is that even before ingesting, that means even before saving it or storing it in a Druid format, internal format, it can summarize the data so that your queries can be even more faster. I'll show you a lot of use cases for this. So these are the most key features in Druid. So we can start. I'll showing you how to use Druid in first. So there are two main processes in Druid. One is ingestion and query.
Ali,
So
on the previous slide, so I'm not sure if everybody knows about columnar storage. So maybe.
okay. So the is that usually if you go with MongoDB, if you want to start querying the data, so what happens is it has to go to with respect to the row. So that is one format. But in columnar storage, what happens is if you query with respect to the columns, the data which the storage which the database will have to query will be on with respect to the columns. So in this way, it will be very efficient in processing the data. This will not load all the unnecessary columns which are not required. Uh, if I'm wrong, and someone can correct me.
Yeah, so basically what happens is that let's say the column is what is some flag like is it available, okay? Then there will be mostly the values like yes, yes, no, and all, right? So column, what happens in row storage is that you store the each row. So for each product you store yeah, it's available or not available and all, right? In columnar storage, you are just storing that column as yes, no, and all. And and you optimize it a lot. So for example, you simply say yes, and it is yes for 10 rows. And you just mention that saying yes for 10 rows, and then say no for next 13, and then yes for another 20, like that. So it compresses the data considerably. And that's why it's also very fast to search with respect to when you index them, right? So the columnar storage becomes faster to index and then get the values also out of it. So, and it is stored with respect to row number. So for first row, the data would be first, and second row, the data would be second. So the columnar storage works like that. Yeah. So I think the Parquet is also columnar storage, right? Parquet file.
Yes. So I'll go next. So now we'll start. I'll start showing how to use Druid and how we can load data. So there are two main processes in Druid. One is ingestion and query. So what is ingestion? Ingestion is loading the data in your Druid. So there are two ways. One is streaming and batch. In streaming, what happens is in real time, the data as the data is coming, it'll start indexing and storing the data in Druid. And in batch, what happens is you already have data somewhere stored. You can say in bucket or in your local or Hadoop assay. You can you'll just use it to load that whole data in the in Druid. So in batch as well, there are multiple ways. So one is you can have batch parallel. What happens is it'll start running its process in parallel ways. It'll try to divide the data and try to run it. And in Hadoop based, everything is at a time. You can only override. And in native batch, what happens is it'll run only in single thread or single process. And next, in while ingestion, what are the data model? In data model, in the sense like what are the main things while you ingest a data? So one thing is data source. So you can consider data source as a table in relational databases. So any source, any data will be called a data source if you have read it from Kafka. So one topic, so you can call like a table. Even in Kafka, topic will have events like a table where all one particular type of events. If you are reading that, so it will become a data source in Druid. It is the name which has been given as data source. And another thing is that every row or everything which you have, it must have a timestamp. As I said, it must be your since it has taken a concept from time series database. And second thing is, third thing is dimension. So if you want to store something as it is, you can say, you can call it as a categorical or a value which must be as it is. You don't want to alter it. It is a dimension. And another thing, metrics are mostly columns where you want to store it in an aggregated form, or you can call it as a numerical form as well, because you can aggregate numericals most of the time. And this is a spec, so I'll take you through it. So right now, if I go take you, this is a Druid console. If you run a Druid, this is a UI console where you can see all your Druid processes. Now I want to load the data for ingestion. Is the screen visible to everyone?
Yes.
Yep.
Yeah. Okay. So I'm trying to load the data right now. So I'll say start new spec. So these are the things which are available, readily available on Druid. I can connect Kafka, Kinesis, Azure, Amazon S3, Data Lake, cloud storage, HDFS, and I can reindex a Druid from another data source, HTTP, local disk. So right now, what I'll do is I'll just take local disk. In local disk, we can give a base path. And file. One. And I'll have to apply. So this is the example data which is already there in that file, JSON file. Next is I'll pass the data. It will pass the JSON file. And few things while doing here is Druid does not support multi-level indexing. That means if you columns, that means inside a column you have another few columns, that is JSON inside of JSON, or in that format. It doesn't support that. So you'll have to flatten it. So a lot of times it gives you the option of flattening your columns, and usually it's very easy here using it in UI. And next, what we'll do is, so data source is done. Next is timestamp dimension. So next is time. So right here we have to give which is a time component. That is a timestamp. As soon as you give timestamp, you have a lot of formats. Usually, most of the time, it understands. It figures it out by itself, and it'll convert it to its own time format. Next, transformation. So here, even before ingesting the data inside a Druid, you can transform the data according to your needs. So right now I have bytes. I want to convert it to megabytes even before adding it, because I don't want the overhead of converting the columns into bytes while querying. So what I can do is I can convert it to MB, and I can say, okay, divided by 1024. So I'll say apply. So what will happen is this will become into MB. I'll just make it, yeah, apply. So this is the transformation stage. So timestamp dimensions. So next we'll go into filtering. So if you want to filter out the data and you want to move forward, so that these are the ways where you can save your time and the memory in later stages. So even before adding the data. So if I want to just select a user with this IP itself, so I'll say I can just click on this and I can say, okay, this is the guy I want only this guy. So I can filter out only this this IP. So right now I'll remove this and I'll go to next, configuring the schema. this is where main things happen. So right now, these all are the specs, and there are a lot of data schemas. So I'll go to the next right now. So one more thing during ingestion, what a very amazing thing in Druid is you can pre-aggregate or summarize your data even before ingesting it. That means in this way, now let's consider IoT devices where I want to have analytics on IoT devices. What will happen is you want to keep a track of all your devices, how much data it is giving and how much packets are coming, how much it's fault tolerant. So those things are usually the IoT cases. So here, if I try to save each and every event, so what happens is in each second, there might be a chance that you want it. It's very important. So what will happen is in each second or each 5-10 seconds, you'll have approximately 10 to 20 events. That is just too much to store it, right? So what you can do is you can just summarize them in that format. So that's called a roll up. So it will pre-summarize and you can save it. In this, what will happen is here I just remove this. So what these are, it'll auto detect and it'll do things. So this is your normal data. So now I want to roll up. I'll say roll up, enable roll up. So it'll just find all your numerical values in this table and it just auto detects and runs a count on them. So here it has given count. So that means it, so here number of packets. So what this means is, or it said, if I remove cancel rollup, if I remove rollups, first you see that number of packets it is showing. Now I can say that while rollup, if I enable rollup, I can just count number of packets it has counted and it has summed them up. Cancel. Now here I'll remove. So before even pre-summarizing, you can say that according to how much time base you want to summarize it. So here, if I give none, it will be nothing. Next, if I say second, it is nothing because these are very much apart. Next is minute. As soon as I come into minute, here in count, it says that, okay, there were 3 rows, it has been summarized to 1. And second is, it has summed all the bytes. And next, the in megabytes, it has become 33 MB. And how many packets? So this was one of the column. So how many packets were there? So it has become 286 because it has been summed. So in case you want to get the average out of this, you can just divide it by the count. In this way, you can aggregate all your data and save memory and even run your queries as well. So this is a very huge boon. Now I've applied it for the minutes. In now, main thing when you roll up is you cannot come back to your single events. If you think that you have to again come back to the single events and run a query, that's not possible. As soon as you roll up, this is how the data will be. Now I'll make it 2 minutes just to have more rows. And next, partitioning. Usually, so as I said, in time series database, everything is with respect to the time. So having your data, how it is stored is very important. So how do you want to be store your events? So here you can say that how do I want to store? So segments. So what does segment mean here is that all events in Druid is stored with respect to segments, and each segment can be with respect to your time frame, that is hour, minutes, seconds, or days and month as well. So here I say that, okay, I want to store it with respect to hours. All your events, every hour, it will make a segment and save it. And next, I'll tune. So these are all your IO configs where while ingesting your data, how you want to do the configurations. Right now, I'll keep it default. And next, publish. When I try to publish it, okay, do I want to append the data? No. If I want to append it again, so it will append true. So edit specs. So what we see here in a JSON format is the native format of Druid. This is how the Druid takes it as. So what all we have done here in UI, it has taken that, converted to its own native JSON format and stored it here. And using this, we can submit and it will be converted to a task. So this will be running and this will run and have an index. It will start indexing. So this is still running now. So few things. Few things as a recall. A data schema is where all you'll have data source, times, dimensions, metrics. You can configure it, and when you come to IO config place, where you'll specify how you want to read the data from specific data source. And tuning config is how you want to tune it, how you want to read it. So some places you want parallel, so you can ask the task to have 2 3 processes run on it, or if you want just one, it'll run. If you have maximum tries, how much maximum tries do you want, or how much minutes it must take. So these are the things which tuning config gives. So before I move forward, do you guys have any doubts regarding ingestion? That means loading the data to Druid.
Hi, this is Hiren. I have just like one question.
Yes.
This ingestion part is just to calculate and perform operations on the incoming data, right?
Actually, that is roll up what you're telling. So actually, ingestion part is saying that how loading the data to Druid.
Okay.
Whatever data is coming, I want to load it. Just like SQL, you want to save the data in SQL or MongoDB.
Okay.
Here, ingestion is like you load the data to Druid.
Oh.
But rollups is where it's a feature you can say where it gives you a where it's very easy for you to aggregate the data. So once you want to do a real-time analytics, you want to save your time, memory, and effort. Okay. So if there are a lot of metrics where you say that I want to just aggregate them or do some pre-computation before saving it, rather than doing it while querying. So the rollups and transformations will help you to change to whatever format you want and save it.
Okay. And the output part will come next, right? Like.
Yes.
Okay. Yeah. Thanks.
So anyone else have any doubt regarding ingestion?
Can we use Druid instead of Elasticsearch for monitoring, is for getting metrics of Kafka events?
Maybe I can take that after I've explained the whole Druid thing. So maybe then you can understand with so everything is with respect to the data. So after query and everything, maybe I can answer that question.
Okay.
So next, so once ingestion is done, next is querying. I want to query the data. So there are two types which have been supported by Druid. One is SQL, and second thing is it's native JSON. So first, during the early versions of Druid, everything must have been done by JSON. But recently, they have started giving built-in SQL layer as well to run Druid. So this is how the query structure happens. It's usually most of similar to SQL. So it supports Apache Calcite SQL is what they said. So I'll take you. So if I want to query the data here, so what I can do is I can just click query here, and here it will show me all the data. So right now I have already had run some data here. So this is the rollup data, and I'll just say select, and it is showing me the data. And this is the data right now. So now this is showcasing the data. Now if I want okay, now I've run this. Now I want to run native query, that is JSON format. How is Druid interpreting it? So we can come here and we can say explain SQL query. So whatever your query, it changes it and it converts it to native format. So here you will get to know how it is being shown in JSON format. And one more great thing is, if I want to run this JSON format, if I want to know, okay, I have written a JSON query and I want to know how it's happening, I can actually even take this and paste it here. So it'll run based on that as well. So if I run, it'll run it. This is all regarding query. So it's simple. We can use SQL queries as well and JSON queries to run our queries here, and it supports both. Any doubts regarding queries? Because it is a very short topic for this right now. So next I'll be explaining system design, some architecture of Druid. So any questions regarding queries right now? Okay, so next is storage design. So how does Druid store its data? So as I had explained before that it uses something called segments. So here what it does is it takes all your data and it partitions by time. So here in an example, the Druid is partitioning with respect to the day, because I consider my data is not so large enough that I have to partition with respect to the minutes or hours. So it'll be like day. Why this is very important is usually in time series database or in query, if you have a time aspect and you want to group by with respect to that time, it'll be very easy for the Druid to come. Druid will know which chunk of data is where. So it'll just come and it can group by in this chunk. So in this way, it'll be very fast and memory consumption during group bys is very less. So this is one of the major factor why Druid is very fast. And next, design. So before we show how Druid is working, it's very important. It's important to know what all components and processes are involved in Druid. So these are the internal processes of Druid. So they are coordinator, overload, broker, router, historical, and middle manager. So what coordinator does is that in your huge cluster, all your data, how it's how what are the availability of your data is managed by coordinator. Because in case you put a retention or you say that I don't want data below 7 days or older than 7 days, so coordinator manages those availability, saying that okay, it'll hide all other stuffs. So that those things with respect to the data availability is taken care by coordinator. And what does overload do? Now, while ingesting the data, we have seen that we have added and submitted the task. This is for local. Now, in case if I have real-time Kafka, a lot of Kafka tasks are running. So that time what happens is overload will take care of that, how to assign data ingestion overload workloads. And broker is where all your queries are handled. So if I'm giving an SQL query, so broker is where it is hitting to. And actually while explaining, this is one thing I forgot to say, that you can even send a post request for a query. So all these queries must be hit to your broker port, because broker is one who is taking the queries. And next, your router is an operation place where all your tasks or your requests are being routed between across all your internal process. So router is more of an optional process. Historical. Now what happens is once your data has been ingested and it has indexed, so after ingesting, what happens is data is indexed according to your Druid and it is saved. So once it is saved and it has reached its stage, it goes and it is stored in a in a historical node. So what historical node consists of is that all your S3 bucket, your local, those things are come into your historical node. So they are responsible for storing your queryable data. So once it is converted to your Druid format, it is stored in your historical. And middle manager is where all your ingestion happens. So indexing your data and ingesting is taken care by middle manager. And not only that, there are other external dependencies as well when you're running Druid. So one is deep storage. So what does deep storage mean is that your cloud buckets or cloud storage is what your deep storage means. And even HDFS is included in this. Uh, and next is metadata storage. Now, there are a lot of data. So once you have a huge cluster environment of Druid, there'll be a lot of metadata of each instance and process. So those need to be stored. Usually, once if you are in a cluster environment, you can go to your MySQL or SQL DB. And but if you're running a standalone server of a Druid, it has its own RockDB. I think it is RockDB. is architecture diagram. So what happens when with all your processes running here? Let's go with client queries first, because that is where that is more important for that is where you write an SQL. And what happens? Your client query comes, it goes to your broker. From broker, it gets to know, okay, which data, where it is, and what should I do. So broker will send it to your historical, because it knows that, okay, this segment is in this place, that segment is in that place. It'll get queried, and it'll come back, and will send your query aggregated result back. So what happens here in brokers is, one leader broker will be there. He'll get the query. He knows what to do. He'll send it to other brokers. Other brokers are assigned few other historical nodes. So there, it'll send the query to historical nodes, ask them to aggregate and run your query, mini query. It'll become a sub query. That query will come. That query will be there'll be a response of that. Those data is again joined, and again it is sent to the leader, and from leader again it is sent back to your client query. So this is how your client query runs. Okay, next I want to run so what happens to our data? So our data middle manager. So your data server is come. It'll come to your middle manager, historical nodes. Once it is indexed, everything will be historical nodes, and once it has become old enough, it is stored in your deep storage. And all other your metadata, process coordination, leader election, everything is handled by everyone else. Now we had known that coordinator takes care of our data availability, so all this is taken care of here. So this is the architecture diagram. So once knowing all this, since now we have gone through all our how to run Druid, a simple way of running Druid, what are the components, how it is running, what is the architecture. When do you want to use this? So one thing is the data, there must be a time series data. That means all your data must be with respect to your time. That is event driven. Most usually event driven systems have time series data. And your data must have a high cardinality. What does high cardinality mean? High cardinality is that, consider you have a column in a data. So in a database, you have a column. So that column must have a lot of unique values. So the more unique values you have in a column, that is higher the cardinality of your data. Next is, we need to be able to query the data fast. So if you want your data to be very queryable, now your query must run very fast and you need to get the results. Then you can Druid is best for you. And one more thing is, if you want a streaming data to be supported by your database, then Druid is for you. And another thing, if you have very high insertion rate, usually in event-driven system or from Kafka, if you are reading from Kafka in real time, insertion rate is very high and updates are very less. Then Druid will support you. And our queries, aggregation, and reports must it must support aggregation and reporting queries as well. And one more place where we need, and it is very fast, if the latency is very fast, and or you have a time component, because Druid has a lot of optimizations and design choices where you can save your time or have a very good outcome from Druid. And another thing continued is with examples, where all can you use Druid is digital marketing, if you want user analytics or behavior, or if you want application performance. These are a few examples which we had seen already by the companies which have already been used. And OLAP, business intelligence, and IoT, because IoT is where IoT is very much used. Druid is used for IoTs. And once this is done, cons and where you have used. But what are the limitations? It does not give you windowed functionality. Usually, what is Windows functionality for people who don't know? SQL gives you rolling average. So usually you can window your events with respect to time, and you can move and have your operations. So Druid does not give that. And joins. Joins support has been given very recently. So if your joins are very huge, that means you have taken two data sources and you want to join them, and that's the that will lead to a memory issue. So that might not be an optimal or a good choice. Limiting yourself to joins is not doing your not performing joins is very much better in Druid. You can do the pre-processing first with all that, and then ingest it into Druid. That will be the best thing. And one more thing is multi-indexing is not supported. So these are the limitations into it. Okay, limitations is done. So next, okay, if I am okay, limitation, I don't mind with the limitations. I know that I need Druid. What are the problems I have faced in Druid? So so here, if you want to deploy Druid by yourself, or you want a clustered environment by yourself, one thing is, since you know since you have gone through the architecture, there are a lot of components and a lot of external processes as well to scale. So it is a complex architecture. So you need to know it properly while scaling. And one another thing is, in historical notes, a lot of places and in forums, a lot of things, what's happening is JVM process is giving out of memory error, because people until you don't know your use case and what data or how much is your requirement and which component to scale, because Druid gives you the capability of scaling each component according to your need. If you know that, okay, this is my need, saying that, okay, I have a data, it is being stored and historical node, and I want to scale it. Okay, you can scale it. If you know that coordinator, you have a lot of components running on, and a coordinator cannot handle it because it has to take care of availability of data. Okay, you can scale, you can even scale coordinator. Or if you're broker, because you have a lot of queries running, a huge queries, then you can scale the broker. In this way, you can scale a lot of components. But here, understanding each and every component and then scaling them, that is a huge problem. And another thing is keeping your Druid setup available and running without any error, and scaling is even a huge challenge, because you need to know what's happening. Any questions? Okay, do I have internet?
Ali, do we know if they are coming up with the windowing functionality anytime in future? Is there in the roadmap? Do we know anything on that?
Right now, as we saw a lot of documentation and all, no, they say they don't support windowing, because windowing won't be an optimal thing in real time right now.
Okay.
They are saying that pre-compute or whatever things you want to do with windowing and ingest it.
Okay.
So a lot of companies, what they do is they they run with Flink,
Flink,
SAM,
right.
and all before this, and they ingest it to Druid for all. Usually, Druid is more for all business analytics and monitoring stuff. So they say that just this will be more than enough right now. And actually, joins is also very recent. There was no joins before.
Okay. So I think they're expecting some bad jobs or real-time streaming system like Flink and all to do that kind of processing, and Druid can be a very efficient data storage system.
Yes, yes. So, any other question, guys?
Hi Ali, Hiren again. I'm just checking from like data fetching purpose. Like, does it support REST APIs for getting data?
Yes, actually, it supports. It has a lot of support from for REST APIs. So we can send post queries to broker
Okay.
using multiple languages as well, not just curl request, and you can get the data back.
Okay.
And regarding Nashra's question for having track of your systems, so the main thing is like events and event data. How are we storing the event data? Are keeping track of all your architecture or systems? So that is the main thing. Like if just like we saw networks, right? So like that, if we are having any data system or stream running, then yeah, we can use Druid to uh, monitor all the systems.
I think we don't have any UI, right? Like to directly search it means we need to write query for everything, like
Mm,
for filtering out.
actually, we can. So as I showed, right? The native format. So here, if I go to 1 minute data source, and here if I query SQL, think, so it's completely edit compaction configuration. Uh, so everything is actually their whole native is JSON. So what we can do is we can just like just take a JSON and we can hit the request that will automatically run. So it's not like we have to keep going to UI and check it.
Okay, okay. I think if I check in the UI view, Kibana is better to make it search easy to visualize.
Yeah, it's preference. It's each person's preference. So some places you need the functionality of Druid. So on that we can go with a lot of visualization tools. So few are Redash, and one more thing is Apache's Superset, Dash. So we can even go that side as well. Like if in case you need more visualization with Druid's capability.
Okay.
Ali, what are we using for visualization?
Right now we are testing. We are using Redash, but we are again finding more better visualization. Mostly we are testing with Apache Superset as well. Test करेंगे future.
Oh, okay, okay, good, good. Or okay, and is Talent 500 also using Druid? Santosh is not there, no? Yeah. So Ali, do you know if Santosh and Talent 500 team are also using Druid?
No, I don't know about it.
Okay.
But yeah, it's very much in trend Druid for real-time analytics.
Yes. So we did the project for DSD also, right? And we did it on Spark, but we were also exploring. So we actually started the project, and then we thought, okay, maybe Druid would have been a better choice. We haven't done detailed analysis, but yeah, it came later. It became famous after we did that project.
Yes, yes. With Druid, it's so easy that anyone can query. Most of the people know SQL queries, but if you come with Spark, unless and until you need that uh, Spark engine, Bash
Yeah,
thing,
exactly.
then Druid is fine if you have these kind of queries and things to run with.
Sure. And one more thing I wanted to ask was that the architecture which you showed, it had multiple things, right?
Yes, yes.
So do we need like minimum this many number of servers, or if the set is small, then the master itself, like with less number of servers, they can take care of query servers and data servers and all.
So this they have said that they have given standalone services. So if your service is very less, you can have standalone of everything. They have given a proper setup of standalone, but I don't know that we can reduce it. They have their own configurations saying that if this is so much, you will have to increase this so much.
Okay. So इतने nodes चाहिए ही होंगे क्या? I mean, like we will need like 3 or 4 nodes at least.
Yes, yes.
Okay.
That is the biggest challenge with Druid. A lot of people face is that if they want to deploy Druid by themselves, they have to know everything and properly, because they'll come and they'll face a lot of issues.
Okay.
So that is one big challenge.
Yeah, I think as number of components increase, the complexity also increases. So yeah.
Yes, yes, yes. Okay. Any other questions, people?
Can we configure it the data retention in Druid? Like
Yes,
if
yes.
you
Actually, yeah, I'll show you one. So right now I have this data. I've gone to a data source, and now I want to have a retention here. So one segment compaction replicated. Okay, 1 minute. So like, yeah. So retention. If I say here, there are a lot of rules while doing retention. Now, right now, I say that I don't want days more than, I don't want events more than 1 day. So one thing is you need to have load forever like this. You can say what replica you want, one. So this is the priority of order of your retention, how you want if one does not run second one. So here I say load drop before by period. That means any data older than 1 day, just drop it. So
Okay.
it'll run a task and it'll just drop it. So here you need to make changes so that it will log it. Drop before 1 day.
Okay.
So this is one thing. And you can even compaction. You can change your compaction according to your needs. Now you know that okay, I have given a huge I have my segment. I've given it as 1 hour. I don't need that. Maybe I can make a segment of 1 day. You can even change the compaction and you can do it.
Mm-hmm.
And a few other things which you can see supervisor. These are for all your real-time stuffs. So each supervisor will take care of each topic or each real-time stream, and it'll keep indexing the data. And all your tasks you can see here. So in the UI, I'm showing. So here you can see a task. So there are two tasks. One before the talk, I was testing it. So this was one task, and now I just ran another task in front of you guys. So this is how it is running index parallel. So it is trying to index at a time. And another thing here, you can here even here it is a task. Then services. What all services you have, and what are the status you can see here, and we know the ports, which status is in which port. Tire you can check, will refresh. Then one more thing is segments. I think it is not showing segments now. So all your segments you can see here. I don't know why it is not showing. Oh yeah, I have deleted it. Okay. So what happens here is all your segments can be seen here, and sometimes you can even see the status, what's happening. Now, because I added the retention, it has deleted. Because since it was just one, it was very old data, and since I've added 1 month, it has deleted it. In case if your data is coming regularly in real time, it would index it and store it. And one more thing is Apache Druid has a lot of extensions. So here it has Kafka index and HDFS. You can even have Parquet format, AWS S3. It has very much lot of extensions inbuilt, and community extensions as well, where you can just take it and store it, and you can load it. So any other questions? Okay, then that's it.
Just one small question now.
Ah,
Let's say we are streaming from Kafka, right?
yes.
So can we just stream what only 2 days data, something like that,
Mm,
or last 3 days data? Can we stream like that?
I don't know about that. Maybe I'll have to check it whether there's a special feature, special option where I'll have to say. So usually in Kafka, it's a logger, right? If you want to read, you'll have to the data must have a time stamp, and then while you're running, when you're consuming the data, you have to say from this timestamp I want to read, or from this offset I have to read. So maybe I don't know about that. So right now you'll have to you can take it from latest offset. So in Kafka you have earliest offset, that means from the first, or from latest, whatever I have to read. This one I think I'll have to check. I don't know about it.
Okay.
So then I'll end my talk. Thank you guys.
Thank you so much.
Thank you.